Alright, so today we're taking a look at finding both the surface area and volume of pyramids and cones. We're going to focus today on the cone side of it, but we really can make an extension from this to pyramids pretty easily. So the first thing we're taking a look at is the net of a cone. So remember, that's the idea that if I sliced it from the vertex of the top all in a straight line all the way down to the base, I would end up with this curved surface right here. It's a circle with a sector missing from it. Now in this case, we have a new variable we're using here, which is this, which is a lowercase l, kind of looks like a 1 there, but this is referred to as the slant height. Okay? So it is not the height, but it is the slant height of this cone. So in this case right here, if we're taking a look at this cone as is, or the net as is here, we see that that slant height is now the radius of this circle here. Right? Now when this thing was a cone, the base is what's on the right-hand side. It had a radius of r, as you can see, comparing top-down view of that base. So in this case right here, the circumference of that base becomes now the arc of this new sector right here. So if the circumference is equal to 2 pi r over here, the distance hasn't changed at all, or the length hasn't changed at all. It's still going to be 2 pi r, okay, which is kind of weird to think about, but hopefully you can kind of wrap your brain around that. Okay. Now, it says in number 2, that we've labeled everything here, write a proportion that relates the areas of the curved surface of the sector, so that's one up here. So area of, we'll just say the curved surface, over the area of the circle. Now we're talking about the full circle that that is, the curved surface is a portion of. So this is the area of the full circle. Actually like that. And it says that that's going to be equal to the arc length of the curved surface. So we'll say the arc of the curved surface, okay, compared to the arc length of the circle, which is the same thing as saying the circumference of the full circle. Okay, so we actually have some values that we can plug into for this thing. So area of the curved surface, that's what we're searching for, so I'm still going to keep that over. And the area of the full circle right there, remember that's a full circle that we're talking about in the middle there. Its radius is L, so the full circle is going to be pi, instead of r squared, it's L squared. Okay? And that's equal to the area, or sorry, the arc of the curved surface, which we said was 2 pi r. And then the circumference of the full circle, or if this full circle is going to have a radius of L, that means it's going to be 2 pi L. And if we go to clean this up a bit here, we can see the 2's cancel, the pi's cancel. And so I end up with area of the curved surface over pi L squared is equal to just r over L. Okay. And I want to get area of curved surface by itself, so I'm going to multiply both sides by pi L squared. Right, cancels out with that. Pi L squared. Right. So here the L will cancel with one of those L's, but I'm still left with the area of the curved surface. Curve, there we go, is going to be equal to pi r L. Okay, so pi r L. Now remember, that's just the area of the curved surface. So if we're trying to find the surface area of the entire thing here, we can keep that in mind here and say that the surface area of the cone is area of the base plus the area of the curved surface. Remember, the base was the circle on the right-hand side, the pi r squared right there, plus the new expression we have for the curved lengths, which is the pi r L. So this will actually give us the surface area of a cone, pi r squared plus pi r L.